right, this video will go over the sum and difference formulas, section 7.5. So sum and difference formulas for the cosine function, you just have to put these all to memory. What I remember for cosine is that the pattern is cos, sine, sine, and then you switch the sign. So notice here we have addition of two angles, and then we have a minus sign, or we're subtracting these two quantities. And then when you have subtraction, alpha minus beta, then it ends up being addition. And the pattern's always the same, cos, sine, sine. All right, for sine of alpha plus beta or alpha minus beta, the pattern for sine is it goes sine cos, sine, and then it keeps the same sign. So addition stays addition, subtraction stays subtraction. Next for tangent, I recommend you take a minute and try to derive them. Basically, you take the sine angle addition formula divided by the cosine angle addition formula and simplify. So here's how I think of tangent. The numerator looks like you just distributed tangent through, even though we know that's not what's going on. That's what the numerator looks like. And then you always have 1. And then this sign here is the opposite of the sign here. And then you have the two angles from the numerator, tan alpha, tan beta, multiplied by each other, right? So look at the next one. It's going to work too. So the numerator here looks like we just distributed across. And then you have 1, and then this is the opposite sign of the sign here. And then tan alpha, tan beta. The other two talk about the fact that sine and cosine are cofunctions of one another, and you can actually prove them as well using angle subtraction formula. So I'll show you the first one, cosine pi over 2 minus theta, excuse me. So cosine pi over 2 minus theta, remember for cosine angle identity formula, it's cos, sine, sine. So that would be cosine pi over 2 sine of theta. Oh, what am I writing? Cosine. And then switch the sign, so plus sine of pi over 2 sine of theta. Now cosine pi over 2, that's 0, times cosine theta, plus sine of pi over 2 is 1, times sine theta, so that's 0, plus sine theta, which is sine theta. Okay, and you've probably noticed this fact, pi over 2, that's 90 degrees, right? So that basically says that two angles that are complementary, the sine of one will equal the cosine of the other. So like cosine of 30 degrees is the same as sine of 60. You've noticed that before with the unit circle, but here we have this confirmation for all angles that are complementary. All right, so now we're going to use the angle addition formulas to find the exact value of each expression. And the first thing you have to do is figure out what two angles you want to add together so that I can evaluate 17 pi over 12. Well, let's talk about what makes sense. First of all, you're not going to say, oh, I'm going to take 16 pi over 12 and add it to pi over 12. Because guess what? We don't know what pi over 12, sine of pi over 12, cosine of pi over 12 is from the unit circle. That's not going to help me. So you have to break up 17 pi over 12 in a way where you can evaluate those two angles using the unit circle. Okay? So 17 pi over 12, 16 and 1 isn't going to work. Let's see, 15 pi over 12 and 2 pi over 12, that would give me 17 pi over 12. Well, what's 15 pi over 12 reduced to? That's going to be 5 pi over 4. And 2 pi over 12, that reduces to pi over 6. Do I know the values of sine and cosine for 5 pi over 4 and pi over 6 just using the unit circle? I sure do. So this is how we're going to break up 17 pi over 12. So now I have sine of 5 pi over 4 plus pi over 6. And then remember the pattern for sine is it goes sine cos, sine. And then the sign stays the same, so it's going to be addition. And then you put the angles in. So 5 pi over 4, pi over 6, 5 pi over 4, pi over 6. In this case, the order wouldn't matter because we're adding them together. All right, so now sine of 5 pi over 4, that's going to be in quadrant 3, so that's negative rad 2 over 2. Cosine of pi over 6, that's rad 3 over 2. plus cosine of 5 pi over 4 is also negative rad 2 over 2, and sine of pi over 6 is 1/2. And then from here, we're just going to multiply. So rad 2 times rad 3, that's going to be negative rad 6 over 4, plus, and then the second term's also going to be negative. So let me just write minus rad 2 over 4. And then for our final answer, I could put everything together over the same denominator. So negative rad 6 minus rad 2 all over 4. All right, nice job. Okay, cotangent of negative 5 pi over 12. So you have a couple options. You could try to keep the negative in there, or you could pull the negative outside since we know that cotangent is an odd function. So how would we come up with 5 pi over 12? I'm just going to first pull the negative outside. Let's separate this all so it stays nice and tidy. I'm going to write this as negative cotangent 5 pi over 12. And then let's see, what two angles can I add together so I get 5 pi over 12? Well, let's see, 2 pi over 12 and 3 pi over 12, that works, right? I'll work that out here for you. So 2 pi over 12 plus 3 pi over 12, that would give me 5 pi over 12. So then I'd have negative cotangent of 2 pi over 12 is pi over 6, and 3 pi over 12 is pi over 4. Now, I didn't give you a formula for cotangent. So what are you supposed to do? Well, you're supposed to take the formula for tangent and use the reciprocal, right? Since cotangent is the reciprocal of tangent. So that means I'm going to have, don't forget the negative sitting out there. And then you're going to have 1 in the numerator minus tangent of pi over 4 times tangent of pi over 6 over tangent of pi over 4 plus tangent of pi over 6. All right, that was snazzy. So we have negative, let's see, 1 minus, so tangent of pi over 4, that's just 1. Tangent of pi over 6, that's going to be 1 over rad 3, so rad 3 over 3. And then, again, the denominator is going to be 1 plus rad 3 over 3. Okay, let's distribute this negative through the numerator so it's not being a source of concern. So I'll have negative 1 plus rad 3 over 3 over 1 plus rad 3 over 3. Now this is a complex fraction. So what I need to do is clear out the denominator. I'm going to multiply everything by 3. Okay. And then now I'm going to have negative 3 plus rad 3 over 3 plus rad 3. Can we leave our answer like that? Only if you want a couple points taken off. So you have to rationalize the denominator. And anytime you have addition or subtraction and you need to rationalize, you have to multiply by the conjugate. So I'm going to multiply by 3 minus rad 3. And then now in the numerator, I need to FOIL this all out. So let's see here. This is going to give me negative 9 plus 3 rad 3. That's here. Plus another 3 rad 3. And then minus 3. Minus 3 because rad 3 times negative rad 3 is just negative 3. And then in the denominator, the nice thing is I'm just going to get 9 minus 3. Okay, so cleaning up and simplifying a little bit further, let's look at the numerator. I have like terms here, negative 9, negative 3. That's going to give me negative 12. And then I have 6 rad 3. And then in the denominator, I have 6. And then dividing through by 6, now I have negative 2 plus rad 3. At long last, there's our answer. Good. Okay, let's look at the next one. This is a little different. They've already used an angle addition formula, and we have to figure out what the two angles are and which formula it represents. So notice the pattern is cos, cos, sine, sine. So already I know it's going to be a cosine formula. The two angles are 40 degrees and 10 degrees. And then since there's addition here, I know these angles are being subtracted, right? For cosine, it's the opposite. So this is equivalent to cosine of 30 degrees. And we know what that is. That's rad 3 over 2. Very nice. Okay, next one, tangent of 5 pi over 12 plus tangent of 7 pi over 12 over 1 minus tangent 5 pi over 12 times tangent 7 pi over 12. So this is the formula for tangent angle addition, right? So it's going to be 5 pi over 12 plus 7 pi over 12. Well, that's going to be 12 pi over 12, which is tangent of pi. Now, tangent at pi, that's sine divided by cosine. Sine is 0, cosine is 1, so this is equal to 0. All right. Hopefully those are fun because they look like they're going to be more complicated than they really are. You have to be like a detective and figure out which formula was used. All right, moving on now, we're going to establish identities that involve the angle addition formulas. And to be honest, some of these are actually easier than the identities covered in the previous section because all you really need to do is replace the expression with the equivalent angle identity, and then it usually works itself out. It's pretty nice. So on that note, let's start with the left-hand side. And I have sine of alpha plus beta over cosine alpha cosine beta. Okay, so first thing I'm going to do, I'm just going to replace the numerator with the angle addition formula for sine. So it's going to be sine alpha cosine beta, keep the sign the same, cosine alpha sine beta over cosine alpha cosine beta. And then I look at the right-hand side, and since there's two separate terms, it seems a good idea to me that I'm going to separate these two terms in the numerator and write them each over the denominator. So I have sine alpha cosine beta over cosine alpha cosine beta. Ooh, I see how this is going to work. Plus cosine alpha sine beta over cosine alpha cosine beta. All right, so now I can cancel out the cosine beta in the first term and the cosine alpha in the second term. And maybe you see it, we're pretty much home free. So this is sine alpha over cosine alpha plus sine beta over cosine beta. So this is tangent alpha plus tangent beta. Woohoo! And there's our right-hand side. How was that one? Favorite one of the day? All right, example B. Which side do you think we should start with? Yeah, again, the left-hand side, because we can use our angle subtraction formula for cosine. So we have cosine alpha minus beta over sine alpha cosine beta. So in the numerator, let's see, we will have, or let me work down. What am I doing? Underneath. Always work vertically, guys. Okay, cosine alpha cosine beta plus sine alpha sine beta over sine alpha cosine beta. And then again, I have two terms on the right-hand side. So let's split this up. Cosine alpha cosine beta over the denominator. Sine alpha cosine beta plus sine alpha sine beta over sine alpha cosine beta. And then now, cancel, cancel, just like last time. And this is going to be cotangent alpha plus tangent beta. And we're done. This was pretty much like identical process to the previous example. All right, so there's going to be more identities in the homework assignment, but they're a little bit more straightforward than the ones in the previous section, so I think you should enjoy them. All right, now let's go through the following examples Find the exact value of each expression. So here we have sine inverse of rad 3 over 2 and cosine inverse of 1. I want you to think of each of these inverse trig functions, right, as an angle. So let's label them accordingly. So I'll call this alpha, I'll call this beta. Are we able to identify exactly what alpha and beta are equal to at this step? Well, sine inverse of rad 3 over 2, that's pi over 3. And cosine inverse of 1, that's 0. So I can replace the original formula and just write sine of pi over 3 plus 0. So this is going to be sine pi over 3 cosine 0 plus cosine pi over 3 sine 0. So sine of pi over 3, that's going to be rad 3 over 2. Cosine of 0, that's 1. Plus cosine pi over 3, that's 1/2. Sine of 0, 0. So this whole term is gone. And we're just left with rad 3 over 2. Okay, that was our warm-up example. Now we're going to look at something a little more interesting. Because notice I have cosine of tan inverse of 5 over 12. So again, I'll call that alpha. And sine inverse of negative 3 over 5, I'll call that beta. But tan inverse 5 over 12, that's not one of those angles or values that we know from our unit circle. So I'm going to have to draw a triangle. So if alpha equals tan inverse of 5 over 12, then that means tangent of alpha is equal to 5 over 12. And remember, tan inverse is defined in quadrants 1 and 4. So since this is positive, I'm in quadrant 1. So I'm going to draw a triangle in quadrant 1. An alpha triangle. And label it alpha. And tangent is 5 over 12, so that's going to be opposite over adjacent. Then I know the hypotenuse is 13. All right, next I see that sine inverse of negative 3/5 is what we're calling beta. So since beta is sine inverse of negative 3/5, that means sine of beta equals negative 3/5. Well, sine inverse is in quadrants 1 and 4 again, but since it's negative, this must be in quadrant 4. So I'm going to draw another triangle in quadrant 4 for beta. Okay, so let's do blue for beta. So here's beta. Sine is negative 3 over 5. So opposite side is negative 3, hypotenuse is 5, and this side here is going to be 4. All right, so now we're going to use the angle addition formula for cosine, back to the problem that we started with. And just instead of writing tan inverse of 5/12 and sine inverse of negative 3/5, I'm going to write alpha and beta. So this is going to be cosine alpha, cosine beta, plus sine alpha, sine beta. And then now I'm going to go to my triangles to figure out the values. So cosine alpha, I'm going to go to the alpha triangle. Over here, cosine's going to be adjacent over hypotenuse. So that's 12 over 13. Cosine beta, I go to the beta triangle now. And cosine beta is going to be, again, adjacent over hypotenuse. So that's going to be 4 over 5. Okay, see how that works? Plus sine of alpha, now I go to my alpha triangle, that's going to be opposite over hypotenuse, so 5 over 12. And then sine of beta, which is negative 3 over 5. Okay, and then now for multiplying the fractions, you just multiply the numerators, multiply the denominators. The second one's going to be negative 15 over 65, and I end up with 33 over 65. Okay, good. These problems are really great because they check not only that you know the formula, but that you understand inverses, drawing triangles, evaluating. A lot of things can be covered in one problem. Okay, last one like this. So tangent of pi over 4 minus cosine inverse of 3/5. So pi over 4, I know what that is. There's only one angle that's unknown to me, and it's cosine inverse of 3/5. So let's call that alpha, right? We could call it theta if you want. It doesn't really matter. Let's call it theta. So theta is cosine inverse of 3/5. That means cosine of theta is 3/5. Now cosine inverse lives in quadrants 1 and 2. This is positive, so this is going to be in quadrant 1. Okay, so I'm going to draw my triangle for theta. Cosine is 3 over 5, so that's 3, 5, theta. Here's 4. Okay, and then now I'm going to use my tangent angle addition formula. So I have tangent pi over 4 minus tangent, I'm just going to write theta instead of cosine inverse of 3/5, over 1, and then you switch the sign, and then you multiply the two terms from the numerator by each other. So tangent pi over 4, tangent theta. Okay, so tangent pi over 4, hopefully that's your favorite value, that's 1, minus, now tangent of theta, so go to the theta triangle, that's going to be the opposite side over the adjacent side. So that's going to be 4 over 3. Over 1 plus 1 times 4 over 3. Looks good. So 1 minus 4/3. That's 3/3 minus 4/3, so negative 1/3. Over 1 plus 4/3, 3/3 plus 4/3 is 7/3. The 3's cancel out, and I just have a negative 1/7 left over. Boom. So hopefully that was relatively enjoyable, and that concludes section 7.5 on sum and difference formulas.